What if I told you that the innocent-looking image was hiding millions of dollars worth of credit card details? Well, buckle up, because this isn't fiction. It's a reality that is unfolding right now in the vast digital landscape of the internet. Just recently, cybersecurity researchers uncovered a shocking case where hackers had infiltrated an online store. They didn't just steal credit card details at checkout, they went a step further. They hid the stolen details inside an image on the side, a high-resolution product image. And the most chilling part, the image looked completely normal. No one suspected a thing. The hackers were able to download the image, extract the hidden data, and vanish without raising any alarms. This, my friends, is the dark art of steganography, and it is happening right under our noses. It literally happened to me the other week with this image. It all started with the Hack the Box challenge Irked. Like always, I started an nmap scan of the most common ports, grabbed a cup of coffee and waited for the scan to finish. By the way, since we're waiting for the scan to finish, if you want to play along with me, all you need to do is sign up for a Hack the Box subscription via my affiliate link in the description and start the challenge Irked. Or Irked. Oh! The scan is finished. The results showed that the machine was running SSH, a web server, and an RPC bind service of some kind. Now, I could have checked what's running on the RPC bind service, but my web dev sensors were tingling and I went straight to the website. The website only contained a smiley face and the message, IRC is almost working. Seriously, look at the HTML. That's literally all there is. Not even a head tag or a body tag, just an image and a paragraph. I rate this code a 1 out of 10, but it gave me a hint. The machine is running an IRC server. Since my initial scan only scanned for the most common ports, it missed the ports that are related to IRC. I guess I'll be scanning all ports in my initial scan from now on, but for this challenge I decided to Google what port was used by IRC, and the Wikipedia page told me that IRC uses a couple of different ports. Well, I don't really care about the specifics, so I just spun up a port scan of the ports ranging from 6K to 7K and got the result that an IRC server was running on port 6697. It also found out the name of the service, Unreal IRCD. So I put the name in the search exploit tool and got a list of exploits. Nice! An RC that's already baked into MSF console. But like every good hacker, I didn't just blindly launch the MSF console exploit and profit, but I tried to understand the exploit. So I got the Python code and the write-up, and as far as I understand, if the message started with AB, it would then pass the message to the system call. Crazy! After checking the exploit, I set it up and ran it in MSF console. Let's see where this got me. I set the target port and host, the reverse shell payload, and launched it, and after a short while I was greeted by a shell. Now this shell is pretty awful and I wanted to upgrade it. So I used the Python spawn method, as I call it, to get a semi-TTY shell. Still not great, but better than nothing, and as it will turn out, I didn't need to upgrade my shell anyway. But after getting my semi-TTY shell, something crazy happened. I couldn't believe it. I wasn't even the right user to get the user flag. I was just the IRC server user. And after looking everywhere on the machine, all I found was one strange hidden backup file in DJ Mardo's home. It was like finding a single clue in an empty room. And what was in it? Some kind of password. And hold on. What's this? A hint about steganography. Steganography, also known as stego or stag by the cool kids, has been used throughout history as a means of secret communication. During World War II, for example, the German military used a steganographic technique called microdots to embed messages or images within the text of ordinary-looking letters. The messages were hidden in the position of certain words or letters, often in periods or the dots of the lowercase I within the text, and were only decipherable by those who knew the specific method used to extract, enlarge, and encode them. In more recent times, it was also the method that the hackers from the start of this video used. But for us, this means that this challenge has an image, audio file, or even any other kind of file containing a secret file within. After my search on the server, I didn't discover any suspicious looking file, but then it dawned on me. The website. It was so simple that it needed to have some kind of secrets in it. So I switched back to the website and downloaded the image, ready to crack it open and uncover the secrets within. What secrets are stored in your angry face? So here's where things got really interesting. I needed a special tool for this job. StagHide. StagHide is a command line tool that lets you hide and reveal secrets within other files. I even have a short on my channel explaining you how to use StagHide to embed and extract files within files. It was exactly what I needed for this mission. With StagHide, I scanned the file and guess what I found? I found out that there is a file called pass.txt hidden in this image. But there was a catch. It was encrypted and required the password to decrypt it. So remember that backup file on the server? It had a password. Could this be the key to unlock the hidden file? Only one way to find out. I used StagHide again, this time to extract the hidden file. I held my breath, typed in the password and boom! The hidden file revealed another password. A rush of excitement hit me. But where to use this new password? I tried it for the root user of the machine via SSH, but no dice. But then a thought hit me. Could it work for DJ Mardov? Yes, it did. I'm in and I got the user flag. Nice. But as always, I needed to become root. After a quick scan of the system, checking things like the OS, kernel versions, users, groups, and more, I stumbled upon something unusual. There it was, a non-standard SUID binary, intriguingly named view user. An SUID binary is a special type of file in Linux that lets users run it with the file owner's permissions, not their own. It's often used to let regular users run programs needing root privileges or something like sudo. But if a hacker gets to run an SUID binary, they could gain root access, letting them do pretty much anything on the system. I tried to download it and run it with ltrace or strace, but the application was compiled for Intel architecture and I'm running an ARM-based machine and it doesn't even start up. So I decided to inspect it on the server using the strings command and gave it a run there. It looked like an app that handles user permissions. Not quite sure yet, but that's what it said here. It seemed like the app was trying to use, possibly even execute a file in the temp directory. To test this wild theory, a hacked theory, I created a bash file in the temp directory that simply echoes who am I. Once the file was set up, I ran the view user app again and guess what? It returned root. Just like that, this tool seemed to transform me into the root user. Talk about a power upgrade. So I quickly tweaked my bash file to spawn a shell instead of just echoing who I am, and voila, I got a root shell and was able to get the root flag as well. What a journey. So what's the big picture here? Steganography, the art of hiding secrets in plain sight, is a game changer in cybersecurity. Not everything you see online is what it seems. That cute puppy picture? It could be carrying a secret message. Now, if you thought steganography was fascinating, wait till you hear about Kerberos. It's another mind-blowing cybersecurity concept. Want to learn more? Click on the video on the screen and let's dive into the world of Kerberosing together. Trust me, you don't want to miss this.